the previous talk, we said that physics is deeply linked to our experience of the universe. And today I would like to talk to you about how having different assumption of the nature of matter, of what are particles, what is space and what is time, have deep consequence and create different theory for our physicists. And so with that, how can we challenge our understanding of the universe? Through physics, we are using principles that are fundamentally shaping our science. And so one of my personal beliefs happened to be that wonder is at the source of science. Louder, okay. Yes. Does it work?
Maybe pick it up here, Mike.
Okay, is it better? Yeah. Okay. So one of my personal beliefs that wonder is at the source of science, and most of our most wonderful discovery in science started with people looking up at the sky in wonder and in awe, questioning what the phenomena they could observe in the world. One of them being Einstein, who look at light and wonder, what would it feel like? What would it be like to ride on a ray of light? What would one see? And we have a wonderful heritage from his questioning and his wonder. But one of them is also that as a student of physics, we have increasingly more heavy books to learn about. And it is in education today, we can see that there's a more and more focus on specialized approach and technical approach to physics, because since the beginning of the last century, we have so much more knowledge that we need to learn about. And so there's a mathematical rigor that is required, and little place is still left for having discussion, for physical thought about what does that mean, our theory, what we are talking about. And I think it's an important point, because having discussion about the origin of our theory give us the historical context in which the theory have been born. What are the worldview that at the time people had? What are the understandings that they had about the nature of time? And how did that shape the approach to science and the theories that are born from it? So the worldview comes from a German word, and which I will not try to pronounce even after 3 years in Switzerland. But it has a corresponding sense of expressing a wide world perception. So the worldview that we have are the collection of beliefs, of stories, of values, and expectations that we have regarding the world, how it should be, how it should work. And it is especially important in science because it gives us the perspective that science is an evolutive process. When we take the time to look at the evolution of science, we see that its history is full of twists and turns. And having the big picture, we can really highlight that there's a continuous story of evolution with science, and that different views came one after the other and influenced the understanding of the universe we had. It started with Aristotle, the animist, seeing God in everything. Then suddenly we put God at the beginning of the universe. We only needed them as an engineer, starting the universe and nothing else. Then maybe we don't need him at all. Maybe we can do physics with all we have. And then later on in the 19th century, then we put back the idea of organism and evolutive process in science back at the center. However, if we study science with only looking at the mathematics and the theories that today are considered as valuable, we lose the understanding that we emancipate the theory from its context, from its belief and its worldview. And we lose the ability then to be more imaginative and creative. How can we today make them evolve? So when we learn about a theory, we learn about a story that is born from our principle. And the other choice that we have is also to study instead the fundamental principle from which every theory is born. And it gives us the freedom to question why did we make certain choices when quantum mechanics was born? Why did we went for one interpretation over the other? Are those choices still relevant for us today? Do we still hold the same things as true? What are the scientific reasons and methods that are sustaining those choices? And maybe also today, with the advancement in other areas of science, do we have other possibility on the way we consider the reality of space-time, of matter, of particles? Can we have different choices available for us? Because we know that today, our theories are becoming more and more far out, as I learned this week. And so we are more and more looking for ideas that are complex. And a way of doing that is to take the theories that we have and simply increase, we add on to them until hopefully at some point it will make us able to explain more of what we see. But another way to go about it is to look at where did we start, at where the origin. Do we have the right understanding of how things work? And so in a letter from Einstein to London's time in 1919, Einstein told us to distinguish between two kinds of theory. One of them, the constructive theories, and the second one, principle theories. The constructive theories are far more abundant today available, and they are basically description of particular phenomena, field of particles that constitute nature. So having a constructive theory is taking a simple model and trying to build that up to explain complex phenomena that we observe. A different kind of theory or principle theory, which gives us a universal principle that all physical phenomena must obey, whatever is within this universe, whatever field, whatever particle constitute nature. And so how do you build your theory? You basically start from the beginning. You choose what do you really believe is true in this universe. You choose your set of principles from which you want to start, and you study them. You study their consequences. You reproduce all the result that is already available and known to us, and expect some prediction that you can add to science. And I was reminded during one of an introductory course to laws that just as in society, laws they're not the end of the discussion. They're not everything we are supposed to know. They're just the starting point for our reflection. It's where we start to act and to create our scientific model. And in physics, those are the fundamental assumptions that we have about reality, about determinism, about locality, about causality. All those things are indicative of what we see as real in this universe. And in the same way, in the same time, scientific beliefs, principle, are just a strategic choice. It's an experiment. As you start with what you think is true. You study the consequence of your principle, and then you see if your theory brings something interesting that you want to follow. But it is important to understand that when science goes that way, today we have so many different theories available for us, going in so many directions, and they're all complementary to each other because there are as many exploration of different ways, and we're trying to understand the consequences of our belief on that comparison of the universe. And so, in spirit of building our own theory, here's some toys that are on our playground now as science, some principles that are being used nowadays in some new theories, and which are bringing different ideas. So we can think, for example, of principle of causation, which tell us that a causal relation of fundamental object, of fundamental principle of the universe, just like energy and momentum. And taking this principle of causation also tell us that space-time and locality are emergent property, meaning they are not fundamental. Another example of principle is a holographic principle, which tells that information content in a region of space can be encoded on the boundary of that region, much like a hologram. Relationism. Here we take not causation, but relation as the principle at the core of physics. In this view, space does not exist if there is nothing within it. Time does not exist if no event is happening. Principle of locality, much more well known, which tells us that causes must travel through space-time at the speed of light to affect other energy or object. Now this is a fun one because here you have so many options. You can consider time as fundamental, time as emergent. You can consider the universe as timeless. You can consider as temporal. You have so many options to consider time, and every one of them will create a completely different picture of how the universe looks like. And one of my personal favorites, because of the consequence you have, is the other movement, which was invented by David Bohm, a science physicist who view movement as fundamental. In his understanding of the universe, he talked about the undivided wholeness, which for him expressed that in every separate entity and event and action, there is the awareness of the whole present within every part of it. And so in this movement, he sees the universe as an unfolding movement from the implicate order, which is a closed system, to a generative order in which creativity and freedom and novelty is allowed. So there is a nurturing dynamic between the physics that's based on reason and evidence and the physics that is based on belief system, worldview, values, understanding, and questioning the foundation is an exercise that is highly beneficial for any science, any person, but also any physicist, to understand what can I create that is new today? How can I take our current theory and learn from all the wisdom and all the experience we have from hundreds of years, thousands of years, but also how can I know what do I want to keep as valuable for today's understanding, or what view and belief system are no longer relevant? And questioning the principle give us a new template from which we can think more freely and reason and form new understanding of cosmology. Thank you.
Right on time. That was perfect. So we still have a few minutes for questions. If the question arises, just repeat the question.
Is there some theory which is based on the concept that what you can see on Earth is not automatically how nature works everywhere in the universe? Is there some theory like that? Or is every one of these different theories just imposing what they see throughout the whole universe, as if that's how nature works?
Well, most theory relies on the idea, and so, oh yes, so the question is, are there some theory which
accepts that what we see, how nature operates here, is not automatically how it operates throughout the whole universe in other realms.
Which explain that how what we see here on Earth is different than what's happening in other realms. So I think one of the most fundamental principles is science is that the laws that are happening at some parts of the universe are also applicable to any part of the universe. And so I'm not really aware of theory which have different conception. There is now also some ideas regarding times when you with different principle of considering time. Some theory are now considering that the laws can change and evolve and not necessarily static, so that maybe the law of physics where they were as they were at the beginning of the universe are not the same that we have today. Yes.
Yes.
Very nice presentation. Thank you. You mentioned story, and I was thinking how in the so-called postmodern turn of what I guess we want to call the humanities, there's been a wanting to cut down and get rid of so-called meta narratives. And it just strikes me now that it seems like on the science side, it's just the opposite. The attempt is always to create a meta-narrative, to tell the story of the universe. Maybe you could say something.
Yes,
After repeating.
Can we just give the microphone to the people asking?
Yes, that will be.
We have a room mic now, so we can hear your question.
Okay, so don't need to repeat. I use also the word story because I found it very interesting. For example, if we take science and we take another culture, another vision of the universe that is present in another philosophy, there is often this trying of linking, making comparison of here's what we believe, here's what we believe, and trying to match to see how they can correlate and work together. And if not, then we cannot work together. And when we look at theory in terms of principle and in terms of stories, then it helps us to understand maybe if we want to communicate across discipline, we need to go beyond the story and the understanding we have of our theory. But we need to understand, do we have the same value at the core of them? Are we starting from the same fundamental understanding? And then maybe we can have better discussion because we can have better understanding of each other's vocabulary, where we are starting from and also where we are going.
Yeah, last question, and then we'll have a 10-minute break.
Okay, this is just an appreciation. I really appreciated the way that you started with principles and the values that are embedded in that, and then the way in which the stories express those values. You know, not being a scientist, but rather a humanist, often my students will ask me after the study of multiple systems of Vedanta, how do I know which one is right, or which one to follow or to practice, when they all seem so convincing in their own internal systems. And often the answer I give them is along these lines, that ask yourself, what are the basic principles and the values embedded in these principles, and then ask yourself, what kind of world will those principles create? Rather than starting from the nuts and bolts of the world and trying to derive those principles, start by asking, what kind of world do you want to live in? And then find the system that can derive that world for you, whether it's an impersonal world or a personal one, or it's one that somehow combines those ideas. So I really appreciated the approach that you took there. Thank you.